Hi and welcome to our next level 2 probability video. In this video we're talking expected value. Expected value is a term used to mean how many times do we expect something to happen from a given number of trials. For example, if we rolled a die 30 times, we would expect 5 4s to be rolled. Probability of rolling a 4 is 1 chance out of 6. And if we did it 30 times, a sixth of 30 makes 5. So here's a little formula that will be useful as we solve a little bit more complicated problems. The expected value is equal to n times p. N is the number of trials that the event is conducted, and p is the probability of the event occurring. If we rolled a die 30 times, we would expect 5 4s. We just talked about that, but here's how the rule works. 30 is the number of trials, and a 6 is the probability. So we're going to go 30 times a 6, which is the same as a sixth of 30, and a sixth of 30 is 5. So we expect 5 4s to come up. We expect 5 of each number to come up, to be honest. All right, we're going to go through 3 quick examples, all based on the skills we've just done on the level 12, the normal distribution, the probability tree, and a probability table. If I go too fast, you have to go back and learn each of these different skills separately, all right? So here's example 1. Do you remember about the babies being born at Wellington? They have a mean mass of 2.6, standard deviation of 0.3. So here's my question. If 300 babies were born during June, how many of these babies would you expect to have a mass less than 3 kilograms? So let's very quickly race through the working, and again go back and look at videos if you're rusty on this. Here's 3 kilograms. Let's go to the calculator. Statistics, distribution, normal cumulative distribution. Let's enter in the lower boundary, which is well and truly to the left, the upper boundary of 3, the sigma, which is the standard deviation of 0.3, and mu, which is the mean of 2.6, and let's get a probability of 0.90878878. We'll round it to 4 significant figures to 0.9088. Now, to solve the problem about how many babies, let's go to expected value equals n times p. There were 300 babies born in June, so times that by the probability of having a mass less than 3, and we're going to get about 273 babies. So we're going to say we would expect about 273 babies to be born in June with a mass less than 3 kilograms. Right, example 2. 2 cards are drawn from a pack of cards, a total of 20 times with no replacement. How many times would you expect to have exactly 1 heart? Now, we did this problem in one of the videos, so here's the probability tree we came up with. And since we're focused on exactly 1 heart, it could be this option, which is this probability, or this option, which is this probability. Remember, we add the 2 probabilities to get the total probability of both options, which is 13 chances out of 34. Now we're doing this 20 times. This whole experiment's been repeated 20 times. So let's go number of times, which is 20, times the probability, which is 13 chances out of 34, and that rounds to about 8. So 8 times we would expect to get exactly 1 heart out of the 20 times we did it. Right, finally, here's a probability table and the same type of question. If another 500 drivers that had their learner's license were pulled over, how many would you expect to have a speeding ticket? Well, let's look at the learner's license people. Let's look at those that got a speeding ticket, 14 people out of 159. That's the probability. And let's go and work out the expected value. There are another 500 drivers, so 500 times 14 chances out of 159 rounds to about 44. So we would expect about 44 out of the 500 drivers that had their learner's license to get a speeding ticket. All right, thank you very much for watching.